recording, and let's see what's happening here. And go.
Hi, my name's Melissa.
My name's Carly.
My name's Steven.
We're going to be talking to you today on how wood stoves work.
I'm just going to go over what we're going to cover in our presentation. We're going to start off with the basics and discuss what thermal energy is. We're going to talk about what chemical bonding is, heat and temperature, and then we're going to discuss open fires versus wood stoves in homes, conduction, convection, and radiation in wood stoves, and then how a room gets warm. So what is thermal energy? Thermal energy, according to the UC Davis chemwiki.edu, is the internal kinetic energy due to random motion of molecules in a system. This is also known as heat, and when you burn a log into a wood stove, it goes from chemical potential energy to thermal energy. And then the more thermal energy it has, the warmer the room gets. And then what is chemical bonding? According to how things work, the physics of everyday life, potential energy atoms attract each other but repel when they are too close. And then when molecules do not attract nor repel, they're at an equilibrium state. Lastly, two atoms that have excessive energy will vibrate beyond their equilibrium. A chemical bond is formed when two molecules are forced together and they lose chemical potential energy because they cannot separate unless the energy is returned back to the molecule. And then within the wood stove, in the log, it's disassembled by the thermal motion. And then heat and temperature, according to the UC Davis Wikipedia site, the relationship between thermal energy and the temperature of the system is more molecules present. The greater the movement of the molecules within a given system, the greater the temperature and the greater the thermal energy.
Alright, so open fires versus wood stoves. What is cellulose? Cellulose is a long carbohydrate molecule that is commonly found in wood. Wood isn't actually pure cellulose though. It also contains many complex resins that don't burn well, and that's what creates smoke. So if you plan to breathe the air in which you're burning the fuel, it's actually a bad choice because it's actually harmful to your body. In this situation, you would be better off with a kerosene or natural gas, which both are nearly pure hydrocarbons that burn clearly and cleanly. Wood can actually be converted to a cleaner fuel by baking it in an airless oven to remove all of its harmful resins. This process converts the wood into charcoal, which then burns to form nearly pure carbon dioxide, water vapor, and ash. Okay, so fireplaces are considered a safety hazard because they consume the room's oxygen, and the rising smoke from a fireplace also takes much of the fire's thermal energy and then some of the room's air as well, so pulls it out. That's why rooms are usually drafty, by the fireplace, so when you go over it's kind of cold. The cold air from the outside seeps through the cracks of the chimney. Okay, so wood stove. The fumes from the wood stove, it burns the wood up through the chimney, but before its thermal energy can follow the fumes outside, a well-designed wood stove usually transfers most of that energy into the room, which heats it up. A wood stove is an example of a heat exchanger, and a heat exchanger is a device that transfers heat without actually transferring the hot molecules themselves. It transfers most of the energy into the room without fumes. Alright, so conduction within wood stoves. What is conduction? Conduction is the process by which heat energy is transmitted through collisions between neighboring molecules. So how the electrons and the conduction work together. The electrons move freely throughout the atoms that are transferring heat because electrons can actually carry electricity. Thermal conductivity, Carly kind of defined it earlier, but I have it down as the measure of how rapidly heat flows through a material when it is exposed at different temperatures. But she covered it pretty well, so it's kind of a broad definition. Next slide, please. Alright, so convection within wood stoves. Convection is the heat transfer by mass motion of a fluid such as air or water when the heated fluid is caused to move away from the source of heat, carrying the energy with it. Alright, so here's a scenario. So if a fan was added to a room where a wood stove was used, it would actually help circulate the hot air around the room and make the wood stove itself more effective. And this forced convection still transfers heat from the stove to the colder parts of the room. The wood stove will not have to rely on the buoyant forces of the room.
Alright, so according to our textbook, How Things Work, The Physics of Everyday Life, written by Lewis A. Bloomfield, it is stated that radiation is another mechanism of heat transfer, and we already know that radiation occurs directly through space. So, as the particles inside the material move about with thermal energy, they emit and absorb electromagnetic radiation. And radiative heat transfer happens even when two objects have nothing in between them at all. And everything emits thermal radiation, however, the amount of emission depends on the temperature. So the hotter the temperature, the more thermal radiation is going to give off, and same on the flip side. So if the temperature is not that high, it's not going to give off as much thermal radiation. Radiation transfers a great deal of heat from the wood stove surface to the surrounding objects. And in a wood stove, the red glow from the hot coal is the thermal radiation. The wood stove bathes the room in infrared light, which will warm everything it comes in contact with. So how does a room get warm? So when you light the wood stove, its heat will begin to flow out into the whole room. And in the book, there's an example, and it's saying that a once frigid brass bowl near the wood stove is soon warm to touch. And because the bowl's temperature increases when heat is flowing into it, its overall temperature must be proportional to the added heat. And this constant of proportionality is called heat capacity. And if you have an assortment of bowls, you will notice that some of them will warm up at different speeds and temperature next to a wood stove. So for example, if you have a bowl made out of copper or brass or a different material, you're going to notice that some of them are going to warm up at different temperatures and different speeds. They're not all going to be the same. And you're going to use specific heat, which is going to be, you characterize different materials by its heat capacity per unit mass. So you're going to take the heat capacity, divide that by the mass, and like I said, you're going to use this in order to find the specific heat of the material. So, in conclusion, we know that a wood stove burns wood and air to obtain hot gas, and the burning process is a chemical reaction in which molecules in the wood and air are disassembled into fragments and reassembled into new, more tightly bonded molecules. And this reassembly process releases more energy than was required to disassemble the original wood and oxygen molecules. And then this extra energy appears as thermal energy within the reaction. Rather than distributing the hot burned gas directly to a room, the wood stove transfers heat from the burned gas into clean air or water. And heat is conducted through the walls of the wood stove and then flows through the room through convection radiation, which we've talked about, which are transfer of heat. Any questions?
Thank you. Questions?
Did you do any observations of this? Like, did you work any wood stoves or fireplaces or fires?
We just took the experiment in our books, used that, and I mean, I'm sure you've seen a wood stove before, or like been near like a fireplace in that sort of sense.
Yeah, the example in the book just talks about the bowls, and there's actually a chart saying which material and warms up at different heat. So if you want to look in your book, it'll literally lay it out for you. And
Page 206.
More questions? Why are they black, wood stoves?
Black's a good color for conducting heat.
Radiating.
Or radiating heat, yeah.
Yeah, okay. Good. Anybody else with questions? All right, thank you.